when a function is increasing, it's going up, and when it's decreasing, it's going down. The graph is going up, the graph is going down. So at the top, it stops. So the derivative, when the derivative is positive, that tells you a curve is going up. When the derivative is negative, it tells you the curve is going down. And when the derivative is 0, that tells you that the curve has stopped. It's not always a maximum or a minimum, but it's a flat spot. It has ceased to increase. And now it either decreases or it increases some more. So where's a piece of chalk? So if you go from positive to negative, right, you have a positive derivative. That's f prime is greater than 0. Here f prime is less than 0. Here f prime equals 0. But you could also have a function that goes like this. And right there, it's 0. So here, it's going up and it's going up again. So you would go positive, 0, and positive. So you can have a flat spot on a curve, like x to the 5th. Okay? And you could go down. So if you're down, you're decreasing and then increasing in 0. Or of course, you can go down and get flat. Now these all assume a continuous curve. If you have discontinuous, then you could just sort of stop and then jump and go somewhere else. So we're sticking to smooth stuff now, the polynomial. So let's just do another example. Make sure everybody feels good about this. How about, we'll do it together. F of x equals x cubed over 3 minus, well, I'll fix that in a second. Here's my eraser. Minus 2x squared plus 4x minus 1. Okay? So we're going to find the relative extrema, mean, maxima, minima. Extrema, extremes, okay, are extrema includes both maximums and minimums. Okay? So what you're going to do is find the first derivative and set it equal to 0. So the first derivative, let's see, you bring the 3 down, the 3's cancel, you get x squared minus 4x plus 4, and then we're going to set that equal to 0. I'm regretting picking this problem, but why not? That's what happens when you just point to one in the book and go. Okay, so now we need to find when this is 0. So this is quadratic. You remember 8th grade, we did quadratics. And when you wondered why, this is why. So you only get one 0. It's got a 0 at x equals 2. And this is, by the way, this is x minus 2 squared, right? So something squared is always positive or 0. So you don't really need to sign test this. It's always going to be positive. But just to be sure, you pick a number less than 2, like 0. And you plug it in, and you're going to get 4, so it's going to be positive. So the curve's going up. It's flat at 2 because the derivative is 0. Remember, derivative of 0 means you have a horizontal tangent line. So nothing's happening at that instant. When I say nothing's happening, it just means you've stopped. Okay? But really only for an instant. So you throw the chalk up, you throw the chalk down, it stops at the top, but it doesn't stay there. It'd be fun, you know, in Harry Potter you get it to stay there. They say something usually, but I didn't go to that class because I'm a muggle. People are going to watch this video 30 years from now and go, what's a muggle? All right. Now I pick a number bigger than 2, like 3. 3 minus 2 is positive, 3 minus 2 is positive, so it's positive again. So it's still going up, so this is going to be a flat spot. So this is a curve where nothing interesting happens at 2, it just stops for a second. You know, you're driving, you stop to go to the bathroom, and then you drive some more, okay? That easily can be something that this is modeling. Then you just need to know what's the y coordinate that goes with x equals 2. Well, you plug in 2, and you get f at 2. Remember, that's how you find the y coordinate. You always plug in the original equation. That's 8 thirds minus 8 plus 8 minus 1, which is 5 thirds. Because the 8 and the 8 cancel. Okay, so at 2 comma 5 thirds, so if you're graphing this, you know, let's see, we have an x-intercept at -1, and at 2 comma 5 thirds, for a moment there, the graph is flat. So it either does something weird like that, very unlikely, so don't draw that picture, or more likely, it looks like that. Okay? So as I said, so it's exactly one of those kinds of graphs. It's going up, it stops, and it goes up some more. And when we do second derivative, then you can get a better idea of how to sketch it. So let's do one that's almost identical. And I'll let you guys play with it. How about f of x equals negative x cubed over 3 plus 2x squared and minus 5x plus what? Nope. Plus 5x. Does that work? Yeah. Okay? Try that for a couple minutes. Let's do this one. So, take the derivative. You get f prime of x is negative x squared plus 4x plus 5 is set equal to 0. So some of you stumble at this point because you're not sure how to factor it. Now you could factor it in from there. It's not impossible. One of your factors is negative x and one of your factors is positive x. But to make life easy, if you just multiply this through by -1, you get this, which is definitely factorable. That now factors into x minus 5, x plus 1. So that means that we have two critical values. So what would a test question say? It would say find the critical values, classify them as a maximum or a minimum, sketch. Okay? So go to the number line and put on the zeros. So pick a number less than -1, like -2. This will be a negative quantity. This will be negative. 2 negatives makes a positive. Curve's going up. Right? I can something backwards. Oh, wait, I'm sorry. You need a negative outside of that. Otherwise you end up backwards. So this is negative. Okay? Because remember, you're setting it equal to 0 to solve it, but you can't throw the negative out of the derivative. The derivative is this. Okay? Very important. The derivative is still negative x squared plus 4x plus 5. So if you plug in -2, this will come out negative. If you plug in a number between -1 and 5, you will get positive. So it's going up. If you pick a number bigger than 5, then like 6, it'll be negative and it goes down again.
So what are the zeros?
The zeros are at -1 and 5. So you can, right, you can pull the negative out to find the zeros, but you can't just throw it away. Now we need the y coordinates, so let's see. F of -1 is 1/3 plus 2 minus 5 plus 1, which is -5/3. I think that's right. Okay, got that one right? Okay. And f of 5, it's going to be annoying, -125 thirds plus 50 plus 25 plus 1. So 76 thirds is 228 thirds. So it's 103 thirds. Did I get that one right? Yeah? All right, I'll trust you. So that says that we have minus 1 minus 5 thirds. And that is a minimum. See how it's going down and then up? And we have 103 thirds. As I said in an exam, I wouldn't give you one split. It's quite that messy. And then if you were to graph it, you have some value about there, and some value about there. So your graph does something like that. Okay? How do we do? Well, you don't need the negative if you're just figuring out where this is 0.
Oh.
Okay? Because you would just get negative 0, which is a silly thing, right?
Yeah.
But you still need to keep it in the derivative in general to figure out where the derivative is positive and where the derivative is negative, or you'll get backwards. Okay? All right, so this one confused everybody, but it's good practice. We'll do one more. We'll do one that's slightly different, so not simple polynomial.
Can you plug in the number less than -1?
Correct.
To get that into the original formula?
Right, so what are you plugging into? You can plug it into, so if you have, say, -2, you can either plug it into this, which is circled, or this in factored form. It's easier in factored form, because remember I said you only care about the sign. So if you plug in -2, you say this is -7. That's -1, you multiply that to get, there you get 7, times the negative makes -7. The number isn't important. You just care whether it's positive or negative. So usually factored form is easier for plugging in. Unless you're plugging in 0. Then you just look at the last number. But that's only good for polynomials. It can give you messier problems. Question? Clutching your head in despair. Okay. Other questions? All right, let's do one that's different. It will take a little bit more work. How about... Yeah, you guys are probably ready for one like that. I want to make sure everybody gets this, because this is like a crucial thing. Crucial topic before we move on. Hang on. No, that's right. All right. Okay, let's see if you can do that. One more round of max, min, increasing, decreasing. Okay. Same concept. Take the derivative. That's your first step. Remember, this is calculus class. You only have one tool, derivative. So if you don't know what to do, take the derivative. You'll get something. You'll get some points. So you get 8x cubed minus 64x. Now you have to set that equal to 0 to find the critical values. So 8x cubed minus 64x equals 0. You can pull out an 8x, and you're left with x squared minus 8. You can then either factor x squared minus 8, or just take x squared minus 8 and set it equal to 0. So if you factor it, you get x plus the square root of 8, x minus the square root of 8. You don't really care what the square root of 8 is, it's somewhere between 2 and 3. Right? Square root of 9 is 3. So now let's sign test that. Got 0, negative square root of 8, positive square root of 8. So as I said, square root of 8 is less than 3. So let's try negative 3. If I plug in negative 3, negative 24 is negative. Negative 3 plus 8 will be negative. Negative 3 plus the square root of 8 will be negative. Negative 3 minus the square root of 8 will be negative. 3 negatives makes a negative. Graph's going down. Okay? Again, remember, square root of 8 is 2 point something. Okay? It doesn't really matter now what it is, but it's about 2.8. But whatever. Now pick a number between negative square root of 8 and 0, like negative 1. This is still negative. This will now be positive. This is negative. 2 negatives makes a positive, so the curve's going up. So that's a minimum. Now we plug in 0. 0, we get 0. I'm sorry, plug in a number between 0 and positive square root of 8, I apologize. So like 1, we get positive, positive, negative. So it's going down again, so this one was a maximum. And now we pick a number bigger than the square root of 8, like 3, or a trillion. It doesn't matter, because this will be positive, that'll be positive, and that will be positive. I mean, if you're not sure, you pick a number that you know is bigger than the square root of 8, like 10. Okay? Alright, so that's a minimum again. So you have sort of an idea what the curve's doing. It's going to be sort of W-shaped. Okay, it's going to go down, it's going to go up, it's going to go down, it's going to go up. Now we need to find the y-coordinates. So f of the negative square root of 8, f of 0, f of the positive square root of 8. Well, square root of 8 squared is 8. So square root of 8 to the 4th is 8 squared. So 2 times the square root of 8 to the 4th minus 32 times the square root of 8 squared plus 18. So if you have a calculator, you can do that. Okay, you'll get 128 minus 120 minus 110. Right? Anybody check this in their calculator? Is that one good? I'm going to just trust you. All right. If I plug in 0, I get 18. And if I plug in positive square root of 8, I'm going to get the same thing as when I plugged in negative square root of 8. So you get negative 110 again. So therefore, I have a minimum at negative square root of 8, negative 110, a maximum at 0, 18, and a minimum again at the positive square root of 8, positive 8, comma, negative 110. Remember what I told you? The maximum, it's a relative maximum. So 0, 8, maybe down there, and down there. If you're graphing, it doesn't have to be to scale. Just label your points. Okay, so label them 0, 18. You just want to make sure that we can understand what you're doing when you label these. So these are absolute minimums. They're the absolute lowest that the curve goes. This is not. This is a relative maximum because the curve goes higher on either end. But in this area, locally, it's a maximum. All right, now let's try a more complex graph. How about... f of x equals negative 8 over x squared plus 1. Which, since we're going to take the derivative, you could rewrite as negative 8 times x squared plus 1 to the minus 1. And we want to take the derivative of that. So it's a chain rule. We got f prime of x. Bring down the negative 1, and you get positive 8, x squared plus 1 to the minus 2, times the derivative of the inside. Okay? So again, do the derivative of the outside part. That's the negative 1, x squared plus 1 to the negative 2, times the derivative of the inside. So this is chain rule, which we could then rewrite as 16x over x squared plus 1 squared. And now we're going to need to find critical values, like where is that 0? Well, x squared plus 1 is always positive. Because x squared is always either positive or 0. When x squared is 0, you get 1, otherwise you get a number bigger than 1. So the bottom of this fraction is always positive. So this will only be 0 at x equals 0. So it's your only point you have to worry about. So when you do the derivative and you end up with a rational expression, you're only going to care about where the numerator is 0 to find maxes and mins. You do care about where the denominator is 0 because you could still change sign there. So you can switch from increasing to decreasing, but that won't be a maximum or a minimum. But I don't think we're going to do any of those in this course, so I'm not really too concerned. It's not that kind of a class. All right, so sign test. Pick a number less than 0. How about negative 1? If you plug negative 1 as the numerator is negative, the bottom is always positive, so you get negative, curves going down. Pick a number bigger than 0, like 1. This is 16, that's positive. Top is positive. I mean, the bottom is positive, so it's positive. So now it's going up. Oh, this can't be as easy as a parabola. There's something funny has to be going on. Now we can get the y-coordinate. So when x is 0, f of 0 is negative 8 over 1 is just negative 8. So this has a minimum 0 comma negative 8. So you want to make this into a parabola, but it's not quite got that shape. How do I know? Well, what happens when x is a really big number? Think about the limit for a second. Like what happens when x is a billion? The denominator is really big, so it could be 0-ish. And when x is a negative really big number, the denominator is going to be big, so it could be 0-ish again. This graph is actually going to do something like that. And in, what day is today, Wednesday? Friday's class, I'll show you how you start to figure that stuff out. Okay? So I wouldn't worry just yet about how I got that graph. Okay? Just know that that's what it looks like. All right, let's do another one, because I really just want to analyze the maxes and the mins. How about x to the 5/3? To the 5/3. Well, f prime of x is 5/3 x to the 2/3. Don't you hate those fraction powers? They're really annoying. So the only place this is 0 is at 0. And what does x to the 2/3 mean? It means take the cube root of x and square it. So you could think of this, you don't have to write it this way, but you can think of it as squared. In other words, this is always going to be a positive quantity or a 0. So this derivative is always positive. F at 0 is 0, so it goes through the origin. And it's flat right here. Oops. Ignore that picture. That's such a... It's very hard to do with the board. It's much easier to do it on paper. Do it again. Turns over. One more erasure. Like that. Okay. And it's flat here. So I'm not doing a good job of getting the flatness in there. So those are not asymptotes. It's going up. It's just going up slowly. Do you guys know what the cube root of x looks like? Cube root of x looks like that. So cube root of x to the fifth also looks like that, okay? It's only a small variation on it, so I'm just trying to draw that right. But it's flattening there in the middle. Okay? And how can you tell? Well, you can do some limits. When x is a very big number, this will be a very big number. If you take a trillion and you take the 5/3 of it, it's still a big number. It's just not a trillion anymore. In fact, it's bigger than a trillion. And in negative, it'll go down. So it's going to go up and down, but it's going to go slowly because you're taking cube roots. So the only interesting thing is happening is at 0. Okay, now how do you make this more annoying? Because it's already annoying, but let's make it more annoying. Let's do x to the 2/3 instead of x to the 5/3. Now if you take the derivative, you get 2/3 x to the negative 1/3. Where is that 0? You want to say 0, don't you? It is not. Because remember, this is 1 over cube root of x. So it's actually undefined at 0. What do you mean it's undefined? I mean, it's got 0 in the denominator. So it's infinite in some way. So this is not a maximum or a minimum. So we'll deal with this, as I said, Friday when I start to do concavity. But this is a cusp. It's a point where the denominator goes to 0, so the slope becomes infinite. In fact, it's even more, like that. It's like a ball that's bouncing. So it's very steep and then goes back up. Okay? However, it still changes from increasing to decreasing at 0. So that's what I said, you have to still check a critical point. Because to the left of 0, this quantity is negative, so it's going down. And to the right of 0, it's positive, so it's going up. So even though it's not going to be a maximum or a minimum, it still helps you figure out if the graph is increasing or decreasing. Confused? Probably a little confused. I'd be a little confused. But that's what we have more classes for. So I'll see everybody on Friday. We'll clear it up then.